Hi students, in this video lecture we will understand coordinate bonding. In the previous video we have understood covalent bonding, and we have seen that covalent bond formation takes place by sharing of one or more pair of electrons between the combining atoms, right? And one important thing in the covalent bond formation was that the shared pair of electrons came from both the combining atoms, and both the combining atoms equally contributed to the shared pair of electrons. That is, same number of electrons would come from both the combining atoms. Like in case of hydrogen molecule formation, both the hydrogen atoms contributed one electron each in covalent bond formation, right? Now when we study coordinate bond, in coordinate bond, when a coordinate bond formation takes place between two combining atoms, this shared pair of electrons, instead of coming from both the atoms like in covalent bond formation, would come entirely from one of the combining atoms, right? I'll repeat, in coordinate bond formation, when a coordinate bond gets formed between two atoms, right, the shared pair of electrons would come entirely from one of the combining atoms, right, and would be shared by both, right? So we'll just take example of ammonium and ammonium and hydronium ion formation, right? Ammonium and hydronium ion has a coordinate bond. Let's see the formation of coordinate bond. We know that ammonium ion has a positive charge, and ammonium ion gets formed when proton, or we also call it as a proton or a hydrogen ion, combines with ammonia molecule. It forms ammonium ion. Now let's quickly see how it works. We know that nitrogen has 5 electrons in its outermost shell, right, and it has to combine with 3 hydrogen atoms in the formation of ammonia molecule. So each of these hydrogen atoms will try to acquire 2 electrons in its outermost shell, right, and nitrogen atom will try to acquire 8 electrons in its outermost shell. So it will share 3 electrons from 3 of the combining hydrogen atoms, right, and these hydrogen atoms will also share electrons with nitrogen atoms by forming 3 bonds. These are 3 shared pair of electrons, right, and we can see that in this shared pair of electrons, one electron is contributed by both the combining atoms. So this is covalent bond, where the shared pair of electron is contributed by both the combining atoms. Here combining atoms are nitrogen and hydrogen, right, and this is how now nitrogen has acquired 8 electrons after forming ammonia molecule. 1 2 3 4 5 6 7 8, right, and all these 3 hydrogen atom also has 2 electrons in their outermost shell. So this molecule has become stable after the covalent bond formation. Now nitrogen atom, after forming these 3 bonds, still has a lone pair of electron, still has 2 valence electrons which are left non-bonded, which did not involved in bond formation. These 2 electrons were not involved in bond formation. So these 2 electrons are known as non-bonded electrons or lone pair of electrons, which are not involved in bonding. And this electron pair or a lone pair can be transferred to some other atom which is short of 2 electrons, or an ion or an atom which is short of 2 electrons, right? So if we take the formation of ammonium ion, in the formation of ammonium ion, this proton will combine with ammonia molecule, right? When proton will combine with ammonia molecule, this lone pair of electron would be transferred to hydrogen ion, right, and this shared pair, this is the shared pair of electron in coordinate bond formation. So this shared pair of electron entirely came from one of the combining atoms. Here combining atoms are nitrogen and hydrogen, right? And the shared pair of electron came from nitrogen atom, because it has a lone pair of electron available that it can transfer to some other ion which is short of 2 electrons, right? So this is how bond formed, right? Coordinate bond, this is the coordinate bond, this arrow represents a coordinate bond, and this coordinate bond resulted by transfer of a lone pair of electron from nitrogen to hydrogen ion. So hydrogen ion has acquired 2 electrons, right, and it has become stable, and nitrogen we know was already stable, right? And this shared pair of electron would be shared by both nitrogen and hydrogen. Once it's provided to hydrogen atom, right, this lone pair of electron would be shared by both the combining atoms, that is nitrogen and hydrogen. This will acquire a positive charge. Positive charge came from this proton, hydrogen ion, right? And coordinate bond is represented by arrow pointing from donor to acceptor, right? So just look at the definition. Bond formed between two atoms by sharing a pair of electrons, right? This was the pair of electrons provided by one of the combining atoms. Here combining atoms, one of the combining atoms that provided the shared pair of electron was nitrogen, right? And afterwards this shared pair of electron would be shared by both the combining atoms, right? And let's quickly see the formation of hydronium ion as well. We know that hydronium ion is formed from water molecule plus hydrogen ion, right? So let's see the formation of, since we know that oxygen has 6 electrons in its outermost shell, it will react with 2 hydrogen atoms. So oxygen needs 8 electrons, and hydrogen, each of the hydrogen atom has 1 electron in their outermost shell, so they need 2 electrons in their outermost shell, right? So these hydrogen and oxygen will share 1 electron each, and they will form this shared pair of electrons which results in covalent bond formation, and oxygen is left with these 2 lone pair of electrons. Like we have studied in previous example, these lone pair of electrons can be transferred to some other atom or ion which is short of 2 electrons, right? So in the formation of hydronium ion, this shared pair of electron, one of the shared pair of electron would be transferred to this proton, this hydrogen ion, right, forming a coordinate bond, right? Since we said that in the formation of coordinate bond, the shared pair of electrons would come from one of the combining atoms and would be shared by both the atoms. So here the shared pair of electrons is coming from one of the combining atoms, which is oxygen, and would be shared by both oxygen and hydrogen. Once hydrogen has this shared pair of electron, right, it will acquire stability, since it needs 2 electrons to complete its shell, to complete the doublet, right? So this is how it will form. If we draw the structure of it, this one shared pair of electron was transferred to hydrogen ion, so this has acquired positive charge, right? Positive charge was due to hydrogen ion. So here this oxygen atom was a donor. Like earlier, nitrogen atom was a donor, since it donated its electron pair, so oxygen atom is a donor, and this hydrogen atom or hydrogen ion is a acceptor, since it accepted the electron pair donated by oxygen atom. So from these two examples we can deduce the conditions for the formation of coordinate bond. One of the combining atoms, so in the coordinate bond formation we see that every time one lone pair of electron or shared pair of electron is transferred from one of the combining atoms to the other atom or ion which is short of 2 electrons, which is short of a pair of, or which is short of a pair of electrons. So two things must be there for coordinate bond formation. First is, one of the combining atoms should possess a lone pair of electrons so that it can donate that lone pair of electrons to the other atom, right? And another atom should be short of a pair of electrons so that it can accept that pair of electrons which is donated by the donor atom, right? Another atom should be short of a lone pair of electrons like hydrogen. One of the atoms must have at least one lone pair of electrons like nitrogen in ammonia and oxygen in water molecule. We have already understood this. So donor and acceptor atom which provides electron pair, acceptor atoms accepting the lone pair of electrons like hydrogen in both the cases, right? So since we have studied both the examples, we know that ammonia is a polar covalent molecule and water is a polar covalent molecules. Like we have studied previously, like electrovalent bond forms between a metal and a non-metal, right? And a covalent bond is formed between two non-metals, right? Similarly, if we notice both these examples, we see that in case of hydronium ion, this bond is formed between an atom of a polar molecule and an ion, right? Bond formed between an ion and atom of a polar covalent molecule. Here atom of a polar, which is the atom of a polar covalent molecule, since we know that water is a polar covalent molecule, so oxygen is the atom of a polar covalent molecule, and which is the ion was this hydrogen ion. So bond was formed between water molecule, right? Water, we know water is a polar molecule, so bond is formed between an atom, oxygen atom of a polar water molecule and the hydrogen ion. So this is what it means. And when we studied the example of nitrogen, since we know that nitrogen is also a polar molecule, since nitrogen is more electronegative than hydrogen, so nitrogen has negative charge and all oxygen atom has all hydrogen atoms have positive charge, right? So bond was formed between atom, since this water ammonia is a polar molecule, so bond was formed between atom, nitrogen atom of polar ammonia molecule and an hydrogen ion. I'll repeat, bond was formed between nitrogen atom of polar water molecule, bond was formed between nitrogen atom of polar ammonia molecule and hydrogen ion, right? So one more thing, coordinate bond has properties of both ionic bond and covalent bond. That is why we call it as a semi-polar bond or a co-ionic bond, right? And lone pair of electrons, we know that oxygen and nitrogen in our examples had lone pair of electrons, which and what are those lone pair of electrons? Which were not involved in bonding, right? Pair of electrons which is not shared with any other atom, or which was not involved in bonding, or was not shared by any other atom, was a lone pair of electrons. And what was bond pair? Formed by sharing of electrons between two atoms, like in case of all these other atoms, nitrogen, hydrogen, and these oxygen in water molecule, when two hydrogen atoms combines with oxygen atom, right? So bond pair is like the shared pair in case of covalent bonds, formed by sharing of electrons between two atoms. Now let's quickly see one more example. We need to just quickly, we'll see how hydroxyl or hydroxide ion gets a negative charge. Since we know that water is a since this is the structure of water and oxygen has two lone pair of electrons, right? So when water will ionize, it ionizes like this, right? And we know that since in the formation of hydrogen ion and hydroxyl ion, this one of the OH bond breaks, right? Here one of the OH bond breaks. So when the OH bond breaks, we know that this oxygen has high electronegativity, right? And this hydrogen has low electronegativity. And we know that there is this bond. This bond means there is a shared pair of electrons. This bond is nothing but a shared pair of electron. So oxygen, since oxygen has high electronegativity, that means oxygen will attract this shared pair of electron towards itself, right? So when this bond will break, oxygen atom will acquire this shared pair of electron will remain with oxygen, right? Thereby giving it a negative charge. And hydrogen atom, since it has a less electronegativity, will get dissociate into a positive ion, right? So OH ion minus plus hydrogen ion, right? This negative charge was due to high electronegativity of oxygen atom, and due to high electronegativity of oxygen atom, this shared pair of electron will remain with oxygen atom. Since what is electronegativity? It is the tendency to attract the shared pair of electrons, right? Since oxygen has higher tendency to attract the shared pair of electrons, so this shared pair of electron will remain with oxygen atom, right? So this is it. I hope all this is clear to you, right? There is one more thing. There was a question asked, how many bonds were involved in ammonium chloride molecule? So in ammonium chloride molecule, we have seen that in ammonium ion we have one coordinate bond and three covalent bonds, right? And this has positive charge because of positive hydrogen ion, right? And when ammonium chloride will form, chloride has a negative charge, right? So this ammonium and chloride, due to opposite charges, they develop a high electrostatic force of attraction, right? And will form a electrovalent bond, forming ammonium chloride. So ammonium chloride has three types of bonds: electrovalent bond, which is due to positive and negative charges on ammonium and chloride ion, right? And three covalent bonds, right? In the ammonia molecule, we already know there are three. The three hydrogen atoms are bonded to nitrogen atom via covalent bonds, and there is one coordinate bond to hydrogen ion. We have already understood that in the beginning of this lecture when we gone through the formation of ammonium ion, right? So all this is important, right? Just go through all this. You can take down the notes. Thanks.